Audio Jungle. Audio Jungle.
Or superimposed flow. Now we'll talk about superimposed flow. Okay, so in this superimposed flow means we are going to talk about source plus sink. Now guys, I will show you the that flow pattern. I will show for all type of flow. Mathematical derivation is not important, even though they are not asking also. Okay, so I will show you like what is the flow pattern and what will happen actually. Wherever mathematical derivation is important or stream function potential function formulation is important, there I will derive, otherwise I will show the pattern and I will move ahead now, because all type of flow, if I will go for the derivation, it will be very long actually. Okay, so I will show the flow pattern for the source and sink. So basically we are going to talk about source and sink pair. Now just think, this is what source, check. And this is what sink. This is what source and this is what sink. I must say this is S2 and this is what S1. S1 for source, S2 for sink. Now what will happen? How it will be like? Okay, and there is the distance. Okay, that distance is what I can say. Okay, I will show another. I will not take so much time for this because it is not important for your gate. So we are talking based on gate. Huh? So from the center of the source to this vertical line I have drawn just for the basically a measurement point of view. I am considering this is the one y-axis you can say, or x-axis you can say. Sorry, this is the x-axis. Okay, this side it is x-axis here. So this is what y-axis. So I am considering this is what origin point, no? Origin point. So from this origin to this source it is a distance, and for this sink to this distance is also a. So total distance will be 2a, no? Total distance will be 2a. All right, fine. Now if I draw the flow pattern, then how it will be? This is the source. So source and sink combination you need to see, right? How it will be? Concentrate here, you will understand. It's very simple only, nothing to worry. Okay, because I'm just going to show only the flow pattern. Okay, so guys check. Now I can say this is the source and this is what sink. Okay, so source will, and this is the origin. Okay, this is the origin, this is the sink. I must say S2, this is S1. Okay, now check. So source will originate the flow, so it will originate the flow. So this flow will go like this, it will go towards sink. Why it is going towards sink? Because sink will absorb the flow and source will originate the flow. Similarly here also another streamline, because this is the one another streamline you can say for the source. Okay, so this streamline will be attracted by this sink, so it will be like this. Why it is going like this? Because this is the source, it is originating the flow, and this sink will be absorbing the flow. So automatically, just like a magnet, it will attract towards sink. Okay, similarly downside also it will happen. Yes or no? And many streams line will be there, so you can draw by your own. There should not be any problem. Okay, it is very easy only. Yes or no? So I think this should be very clear to all. One more I will draw. This is the source and this is what sink. Similarly here also. Okay, so sorry, this is not in this way. So this is the flow pattern for what? For the source and sink pair. Always remember this total distance is nothing but A from this side and this is A from this side. Total distance will be 2A. Yes or no? So this is the streamline for the source and sink. Okay, these are the streamlines. If I say, can you draw the potential line? You can draw. How you can draw? Perpendicular. Where will be the perpendicular? You can say like this. Yes or no? Check. Anyhow, you have to draw perpendicular. That's all. Okay. This is the what is this? This is the equipotential line. What is this? This is the streamline. Done. Potential line will be perpendicular to the streamline. Draw, maybe, see, my intention was to show the flow pattern. You draw better. Okay, maybe your flow pattern will little bit looks like different if you draw proper sketching and all. Here roughly I have drawn, but it will comes like this. Okay, done. So the source and sink I have completed. That mathematical formation I told you, for all type of flow I will not give because not required. Okay, done. So this is the like as I told you, that source and sink combination I have given to you. Okay, and mathematical full derivation not required. Okay, it is not required at all. But if you go for the special case of this source and sink combination, then will give the important result. Okay, what is the important result? I'll show you. So doublet is the special case. Okay, special case of source and sink combination. I'll show you. Okay. Doublet flow. So it is a special combination of source and now sink. Now what is the special case? So special case I had shown you. This is what source, okay, and this is the one line, and this is what sink. So from here this distance was A, and from here this distance was A. This was the source S1 and this was the sink S2. Total distance is what? 2A in general. Now if you talk about doublet, so we have a special case. What is the special case? That distance between the source and sink, which is nothing but 2A. If this 2A distance approaches to 0, if 2A distance approaches to 0, then this will be the one special case of the source and sink combination. Okay, what is the 2A distance? It is the distance between the source and sink. Remember, for source and sink, whatever I am saying from starting only, the strength of source and strength of sink will be the same only. What is the difference? Only direction. One will be positive, another will be negative. For magnitude wise it is same. Magnitude wise it is same. There should not be any confusion about it. So 2A is the distance between source and sink. Hope you got it now. This is what source and this is what sink. So the special combination, in a sense, what was the distance between that source and sink? 2A distance. If it is approaching towards 0, then it becomes a doublet flow. Hope you understood what is the special case. Okay, doublet flow is a special case. What is the special case here? Special means that distance between source and sink approaches to 0. That's all. That is the special. Otherwise it will be a simple source and sink combination. So simple source and sink combination will not be called as a doublet flow. All right, done. Now Q is the strength of source as well as sink. Means strength of source and sink, it is Q. Better I will say plus Q and minus Q. If it is plus Q, it is source, minus Q, it is sink. Okay. Then what will be the doublet strength? If you talk about doublet strength, then the product of 2A into strength of source, which is nothing but Q. So, and doublet strength, it is denoted by mu. So what is the mu? Mu is nothing but 2aq. What is the mu? Mu is the strength of source, sorry, strength of doublet. What is q? Strength of source. What is 2a? 2a is the distance between source and sink. Okay, fine. So now for this I will give the equation of stream function. Okay, equation of stream function, equation of stream function for doublet flow psi. What is this? It is nothing but mu upon 2 pi minus mu upon 2 pi sin theta by r. This is the derivation actually, but I am not going to derive. As I told you, it is not required at all. But this formula is very special because from the doublet they are asking problem. Okay, so like you have seen for the source sink, for the uniform flow, in fact for the vertex flow also I have derived stream function and potential function. But for the doublet I'm not going to derive because it's a lengthy and derivation is not important at all. Direct formula, if you remember, it will be better. Wherever it is required, definitely I will give to you. I have explained what is mu. Mu is the strength of doublet or doublet strength. Okay, r is the radius here or radial distance. I will give the parameters. What are the parameters that I will give you? Don't worry. Okay, write down where r is radial distance. Okay, what is the r? R is the radial distance. R is radial distance okay, r is the radial distance. That diagram also I will give, don't worry. Radial distance, and theta is angle made by point P. How that diagram will looks like, I will show you. In short, I will show you that diagram also. So as I told you, derivation is not important. Otherwise, if it is important, then definitely I will give to you. But as I am saying, it is not important. So better you don't bother about the derivation. You just focus on your final value. Okay. Plus Q means source, minus Q means sink. That distance is 2a, which is very less. I am considering one point P. Okay. So basically, this is the point. Okay. So this distance is what? R. And this inclination is what? theta. P is one point. What is P? P is one point. Okay. This is the perpendicular. This is r radial distance. This is theta. Okay. This is the point P. This is what length is y and horizontal length will be x. Hope you understood. This is the sufficient diagram. More than enough. Okay. It is more than enough only. So now stream function psi will be minus mu upon 2 pi sin theta by r. All right. Similarly, you can write equation of potential function. What is the phi? Equation of potential function for doublet flow. What is the phi? Phi will be mu upon 2 pi cos theta by r. This is what equation of potential function. Okay. If I draw the flow pattern, because it is a doublet, flow, pattern. So what is the special condition? Special condition is source and sink distance are very less. It is approaches to zero, means they are almost very close to each other. So if approaches to zero means what? Almost it is going to start at the same point. Yes or no? So wherever it is the source, at the same place you can say there is the sink also. So suppose this is the source. So if distance approaches to zero between source and sink, it means source and sink are at the same point almost. Huh? So if source is what originating the flow like this, so sink will be absorbing the flow like this. Again, if source is or originating the flow, so sink will be absorbing the flow. Similarly here, if source is what originating the flow, so sink will be absorbing the flow. If source is originating the flow, sink will be absorbing the flow. Try to understand it. Source is originating the flow, so sink will be absorbing the flow. Source originating the flow, sink will be absorbing the flow. Source is originating the flow, sink will be absorbing the flow. So almost I'm not able to draw that. It is almost one circle. Okay, it is almost circle, or you can say it is like at shape. If you are able to draw, you can draw like this. Like this. Okay, this is the actual doublet. It we have seen, right? Like this. Nah? So this is the flow pattern for the doublet flow. Understood? Okay. If I say where is the potential line, so potential line also you can draw. Potential line will be what? Perpendicular. Yes or no? Where will be the potential line? It will be perpendicular to the streamline. So it is just like perpendicular. Check. This is the potential line. This one is equipotential line. Yes or no? This is the streamline. Yes or no? 90 degree, exactly 90 degree. Wherever they are crossing to each other, it is 90 degree. All right. So basically, if you check here, better I will remove this figure. Otherwise, you may get confused why there are two figures. It is just for your understanding only. Yes or no? So basically, streamlines lines are circle. Streamlines are circle. Streamlines are circles tangent to x-axis with center on y-axis. All right. So what I have shown you, check the diagram of the streamline and potential line. Again, I will draw. This is the streamline for the doublet. So this is streamline. If you check carefully, so streamlines are tangent to x-axis and center will be on y-axis. Yes or no? Center will be on y-axis. So if I draw separate here, they are talking about this. They are saying it is x-axis and center will be on y axis. Okay, this is the source and this is the sink. One line I am drawing. Anywhere downside also, if you want to draw, you can draw. It is tangent to x axis and center will be on y axis. This is what is streamline. Look carefully. So what will be the equation of circle? Equation of circle. Okay, of streamline in this result is very important. So what will be the equation? I told you this is the one circle. Okay, and for this circle, that it is tangent to x axis and center will be on y axis. This is somewhere it is the center. Okay, so what will be the equation? So equation will be x square plus y plus mu divided by 4 pi psi is equal to mu upon 4 pi psi square. This will be the equation of circle of streamline in doublet flow. Okay, for this okay, now check. So what will be the center of this circle? Center will be what? 0 comma mu upon 4 pi psi. This is very important result. What will be the radius? Radius will be mu upon 4 pi psi. This is the radius. These two results are very important. Once doublet flow will be formed, so definitely streamline will give the circle like this. So that time this equation I am giving, derivation is not important. You have to remember this. Okay. So center for this circle which is forming in doublet flow will be 0 comma mu upon 4 pi psi. What is mu? Strength of doublet. What is psi? It is stream function. Radius is mu upon 4 pi psi. All right. What about the potential function? Because potential function also, equipotential line you have seen here. Check. This is the equipotential line. In previous slides you have seen. Here, see this red one, equipotential line. So if you check, the equipotential lines are the circle tangent to y-axis with center on x-axis. Yes or no? So I can write here equipotential lines potential lines are tangent to y-axis and center on x-axis. One diagram I will draw, flow pattern I will show you, so it will be easy to remember. Check. This is what equipotential line. Yes or no? Actually, it's a circle, okay? It's a circle only. I'm not able to draw that circle. So check this circle. See this circle. So basically, circle is what? Tangent on y-axis. Yes or no? It's a tangent on y-axis and center will be on x-axis. Okay? Center will be on x-axis. All right. Fine. So for this also we need to write the equation. No? Check where is the center. It is tangent on y-axis or not? Yes, it is tangent on y-axis and center will be on x-axis anywhere for any circle. So I must draw single circles. It will be easy to understand. See, it is tangent on y-axis and center will be on x-axis here. Okay. So what will be the equation? So equation of doublet flow in terms of potential function. Yes or no? So x minus mu upon 4 pi phi square plus y square mu upon 4 pi phi square. What is the center here? Center will be on x-axis, hence mu upon 4 pi phi comma 0. This is what center. What is the radius? Radius will be mu upon. So if question will be asked frequently, question will be asked to you. What will be the center when it is streamline? What will be the radius? So this is the center and radius for the streamline in case of doublet flow, and this is the center and radius of the equation for the potential line, equipotential line. Okay, these are the equipotential line. Yes or no? These are the equipotential lines. Done. So this was the enough information for the doublet flow. Okay. Now I'll show one table. Till now what I have explained, it was related to elementary flow, doublet, vortex and uniform flow. Okay. So source and sink. So whatever I have given till now, it is the uh, elementary flow. So just make one table. Okay. Superimposed flow, I'll explain next class. Okay. Today you just write one table here. It is very special. So description of fluid flow, of flow field, velocity potential, stream function, velocity component. Okay. So uniform flow, if you remember, parallel to x-axis, parallel to x-axis, parallel to y-axis. Yes or no? Uniform flow at an angle theta, then source and sink flow, then we have free vertex, doublet flow. Okay. What is the velocity potential when parallel to x-axis? If it is parallel to x-axis, then it was velocity potential phi is equal to stream function. It is psi is equal to, if it is parallel to x-axis, if velocity is what u, it will be y. If it is velocity is u, if it is parallel to x-axis, so parallel to x-axis means ux. Okay. If you remember, velocity will be velocity component. Okay. If it is parallel to x-axis, so for parallel to x-axis only u component will be capital U, v component will be what? 0. Similarly, parallel to y-axis, if you go for the parallel to y-axis, so phi is equal to what? Uy, psi is what? Ux, and u will be 0 and v will be capital U if it is parallel to y-axis. Uniform flow at an angle, so what will be phi? Phi will be u x cos theta y sin theta. Psi is u y cos theta x sin theta. Velocity component you can write by your own, simple only, because both component will come. So u and v both will be there. One will be cos and one will be sin. So u will be u cos theta and v will be u sin theta. Okay. Check source. What is the source? Phi is equal to Strength of source is nothing but Q upon 2 pi ln r. Psi is Q upon 2 pi theta. And for the source flow, what was the tangential velocity? It was 0. What was the radial velocity? It was Q upon 2 pi r. Now we'll go for the free vortex. Phi is equal to, for the free vortex we got I think it was circulation upon 2 pi theta, and psi was minus circulation upon 2 pi ln r. Radial velocity was 0 and tangential velocity was circulation upon 2 pi r. Now coming to doublet flow, just now I have given the result for doublet flow. It was mu upon, check, parallel to y axis it is v. Yes, okay, you take component parallel to y, right? Oh, parallel to y, okay, you take v. Fine. It's only sign convention. Whatever sign convention you want to follow, you follow. Done. Just now you have seen that phi and psi here for the doublet flow. Phi is what? Mu upon 2 pi cos theta by r. Okay, mu upon 2 pi and what is the psi? Mu upon 2 pi sin theta by r. Yes or no? Please write it. What will be the velocity? So velocity both you will get for doublet, I mean radial and tangential both. So that radial will be it is minus mu upon 2 pi cos theta by r square minus mu upon, space is not there, minus mu upon 2 pi cos theta by r square. And what will be the tangential velocity? It will be mu upon 2 pi sin theta by r square. Done. Okay. Anyway, so for today I think this is enough. So much derivation and so much formulation I have given to you. I believe that if you remember the formula, question will be asked. Definitely question will come from this topic only. Beyond this topic, that question will not come. It is sure, because whatever I am teaching, it is from fundamental of aerodynamics, and that is the only book for the aerodynamics. Yes or no? So for that reason I am saying whatever I am teaching, it is enough, more than enough. We focused here. Anyway, so next part, whatever it is, next topic like Rankine half body, Rankine full body will be covered in next lecture. Thank you.